All right.
So question 3, in a pie chart, why are the slices different sizes? Each slice represents a category and area of each slice, and the area of each slice represents a portion of the total occupied by the category.
Yep, sounds good.
How are bar charts and Pareto charts different? Pareto charts are ordered largest to smallest, like from left to right. We conclude that you have this normally distributed if NP is greater or equal to 10, and N1 minus P greater than or equal to 10. Is P the true proportion or the sample proportion? It's the true proportion.
Yep. 6. What is N? N is the sample size.
If P is equal to 1/4, what is the smallest N that satisfies the requirement?
Is it? N.
40, isn't it? Sorry.
Yeah, I was looking it up in the thing again.
Yeah. I didn't see it in the note. Did you find it in the note?
Yeah. Just working it back. So it's, yeah, I'm pretty sure you're right. It's 40.
Yeah, because I didn't see any equation to figure that out, so I just did the math, and that was smallest one that we could get, because the other one, the p times, or the n times minus 1 minus p, sorry,
Yeah, it's small.
satisfies that. That one's easy to get. It's the np is greater than or equal to 10. That's the only way that would happen by 40.
Yep. All right.
Now suppose that n is equal to 24 and p is equal to 4. What is the mean? Isn't it just equal to p? Yeah. So the sample proportion of p halves is normally distributed if n is large. True population mean of the random variable p half is okay. So then it's just 0.4, right? What is the standard deviation of p half?
Here's 10 plus.
Is question 8 right though? Because if you times n by 24, then it's only 9.6.
If you times,
Because remember, in order for it to be normally distributed, it has to follow the whole n times p greater than or equal to 10, and then n times 1 minus p equals greater than or equal.
Fourteen point 24 times 6 is 14.4, and 24 times 0.4 is 9.6.
Well, I don't know what you do if you not.
I'm pretty sure that
Hmm?
the mean of p with the accent is equal to p. I mean, it's right here in the reading, 3.2.2.
Yeah. Mean and standard deviation. It says what is. It says the sample proportion p halves is normally distributed if n is large. So, and to determine if n is large enough, you look up to the one right above it, and you see the requirement. The true population mean of the random sample variable p half is mean of p. So I don't know if that's a conditional statement, like it's only p if n is, or if the is large enough, or if it's
Yeah.
else.
I guess we can't. We don't have enough information to decide that either way. So I think the only way we have to do it is just to do it the way we know.
Okay. Okay, that's fine.
Just assume that's already normally distributed.
Then the standard deviation.
So that's the standard deviation. Let's see. .1. 0.1.
Mm. Yeah. Yeah. That's what I got. Use the following information to answer the next 4 questions. Brittany's batting average is 0.300. We want to determine the probability that she will get more than 35 hits in her next 100 at bat. And is equal to 100 and P is equal to 30. What is P halved? Round to 2 decimals. So to do this, we do 35 divided by 100, right?
Mm-hmm.
So 0.350. Or just 350. What is the standard deviation?
So, point.
Okay. Alright, so I have 0.046. Is that what you got?
Yeah, for the standard deviation. Yep.
Okay. And then the z-score. Sorry, I'm gonna go a little extra. For the z-score, I have negative 1.091.
Yeah, I got 1.091.
Negative or positive?
I got positive.
Okay.
Why I got positive when you got negative?
Oh, I think I put the wrong. I think I put you have. I did. Okay, yeah. So this is the tablet. And there's a probability that Brittany gets at least 35 hits on an X. So when it's at least, where do we shade? Is that
So she needs to get that many or more.
so to
We want to
shade
determine the
it?
probability that she will get more than 35 hits in her next 100 at-bats.
Okay, so then it's 0.13 feet.
Yeah.
Use the following information for the next 3 questions. If the true proportion of people who support a political candidate is P equals 0.52 and N is equal to 2,000 people are surveyed, we want to determine the probability that the result of the survey will suggest the candidate is losing the election, getting less than 50% of the vote.
Okay. Standard deviation.
What is X? Is X 1,000?
X.
Does you mean that in order to get P halved?
So what we want is 50%. We're looking at less. What's the probability of getting less than 50%?
Yes. So how do we find X so that we know what P halved is? Or do we not? Well, we don't need P halved for deviation.
We need.
So the standard deviation, I got 0.011.
Yeah, I'm just doing it in 1 second. What did you get? I got 2.28.
So for standard, let me check and make sure I put in all the right values. With P at 2,000, or N at 2,000 and P at 0.52, I got for the standard deviation 0.011.
I was doing it wrong.
I set it up in an Excel spreadsheet because my calculator was doing weird.
Yeah, you gotta use like a million parentheses to get it to be going. I was doing the z-score. Do that yet.
Now the z-score, the problem is that z-score, nope, it's just a standard deviation. So we need P halved. So 50%.
It's 0.5 because we're assuming we want to know based on if the candidate got less than 50% or less.
Okay, then I got negative 1.790.
negative 1.7.
I got negative 1.790.
90. I got negative 1.789, which is pretty close.
Well, you used 0.5 as p halved, right?
Yeah,
And then your standard deviation was still 0.011.
yeah. So I did. Well, I used the full equation, so I did 0.5 minus
Yeah, I did
0.52.
divided by the standard deviation, right?
So that, yeah. So I got 0.0 negative 0.02 for that, and I divide that by the standard deviation, which is 0.5 times 1 divided by 2,000. Square root all that. I get negative 1.78888543, blah, blah.
Can I screen share, or is that going to take up too much information?
That doesn't matter. Let me do it.
Okay, so I have n, p, p halved, then x. X is not important for this right now. This is the standard deviation I have, and then my z-score is p halved minus p divided by the standard deviation.
Click on the standard deviation.
Oh, the standard deviation?
It might just be Excel rounding. So it's taking the rounded value. That's why we're getting two different ones that are really close. So it's rounding it to like 5 decimal places or whatever, and it's taking that value and then
Yeah.
z-score. Or not. I don't know. That's weird. I don't know why it's doing that. Well,
That is super weird. Okay. Well, regardless, you should get the same thing anyway, right? Did you use your calculator or Excel?
yeah, I used the calculator.
But you should get the same answer though, still, with it being negative 1.
I get negative 1.789.
Okay. You want me to submit it and see if it's right?
Yeah, we can.
I,
Just submit it.
what? I already did the applet and everything. Okay, I got it right.
Huh.
It was negative 1.790, and then if you plug that into the applet and then just shade to the left of the lower bound, then it's 0.037, and everything
Yeah,
else is right.
I get the same area at the end. So
Oh, really?
yeah,
Weird. That is super weird.
probably because it's just so close. You know. It
Yeah.
doesn't-
Okay. Well, thanks for meeting. I have to go vote now that I'm awake. I'll see you guys on Thursday.
Yeah.
Alright. Bye, Dimitri. If you have any questions, just email me or us or everyone. See ya.